Good morning, everyone. Let us see as per the advertisement. I was having the plan to take a demonstration session which will be live at 11 a.m. and had a plan to complete by 11:30. Let me see what is the result of the timing. I have every setup ready. I'm just waiting for my interested viewers to join, or for some of my friends to join. I will start my program. So everything is ready. You can check. They are all kept before the camera. And the today's session is will they compare the magnetic field created by current carrying conductor in different shapes. Why did I call different shapes? If you carry the current on a straight line conductor, it will have a type of impact as far as the magnetic field is concerned nearby. And if you make a solenoid, it will have a little better impact. And if you have a coil, it will have the best effect that we will prove today following experimental setups. And thereafter, I will show you today how the coils are extensively used in our electrical industry. This is my topic, and I will discuss further on that topic. As I have said, I have shown to my viewers through video and upload shots how DC motor works. And on that session, I told our next session will be after completing the detailed discussion of the DC motor, we'll be switching over to the common AC motors we are using in our homes. So let us check. Today final, this is a lamp load. I will show you by comparing. This is the LED lamp load. Where do we fix it? We fix it on the socket. This is my socket. I have already shown you. So let us see whether our lamp loads do affect the magnetic field or not. We will change this lamp. This is a filament lamp. It is difficult to show this one because this is a little thick wire, but this will be the highest effect because this conducts highest amount of current. That also we have already shown in so many videos. We have arranged for straight conductor as before, which I have already shown. Today I will confirm it. This one is the straight conductor. This one is a solenoid conductor, Without core and with core we will verify. And yesterday I have uploaded the impact of the coil. You can see this is a bundle of coil, and I want to show you again today on live program, because you might have seen in the video how do they love each other, this and this magnet. I have already yesterday shown it. See, they hug each other like this. I will show it again today for all my online viewers. So we will start from a straight conductor, and thereafter I will proceed to other items slowly. Even though time will be required, we will take it. No problem. I have limited the time to 11:30. But let me check. See, I switched on the power system and the lamp is glowing. And we will check one by one, starting from this particular conductor and placing it on this parallel to. I have already told you, if you want to verify the magnetic field due to a straight conductor, you should keep it like this. And first you have to see, align your compass to north south. This is your first duty, because that is the normal alignment of any compass on earth. And thereafter the LED is conducting, but it conducts, I have told you, certain milliampere, 20 milliampere or something like that. So which is not very sufficient to prove that there is a magnetic field around this. So for that you need certain high efficient devices, modern gadgets, to show that there is a magnetic field. So to do that, what I am doing, I switch it off. I show it. I will remove it because this is not efficient for our purpose, even though it is lighting. Now what I am doing, I replace it with the filament lamp. Let me search my filament lamp. I have kept it here nearby. So before you, I keep it already fitted. And now let's see whether it is glowing or not. Yes, it is glowing. And now my duty is to show the magnetic effect, not the light. So how do I show? Similar way, I keep it. But you check again, maybe this one will be providing little bit of magnetic field, but not that much, because this lamp also conducts certain milliampere, but highly more than the LED, but near about 100. So let's see, it is slightly deviating. You can check now. Let the compass be stable first. So we make it stable. This is already stable. And when I move it, the conductor, to nearby, it will deviate slightly. You observe it. If I make a further close, that will be more effective, I think. I close it and you observe, when I keep it parallel, this is deviating by, say, maximum to maximum 4 to 5 degree. If you remove, it returns back. If you take, it is deflecting. So that confirms that our magnetic field depends upon the current flowing in the conductor. And now with that particular current in the conductor, I will continue further. What I am to continue further, I will use this coil to show that even though that small amount of current is flowing through the lamp, and that current is also flowing through the coil in the other wire, See, yellow wire and the red wire are the two wires of the source, and red wire I have already shown using straight conductor, and the yellow wire is connected to the lamp. You can check to the lamp through the coil. So let us see, when I keep the needle before all of you and take the coil here, you will find the needle gets deflected. I will show it when I remove it. You see the needle goes to its north south. When I take the coil nearby, it is getting deflected by around 20 degree. Yesterday I had shown using that large lamp, it was almost 30 degree. So this is 20 degree. Maybe 20 degree deflection is quite a remarkable development for all of us. And now I plan to show you using that uh, solenoid. So where to conduct the solenoid, that is to be plan given by you, because the soldering process should not be disturbing us, because this coil has been soldered with our system. So I do not want to kill my time for desoldering. So what I want to plan, I will connect this solenoid in this particular section where the red wire is being connected. So what I'm doing, I connect the solenoid here manually. See, manually means twisting. One end is connected, and the other end of the solenoid is this yellow wire. What I will be doing, I will be feeding in the socket like this point. It is already open, so I feed it. You observe. So by that way, your circuit will be complete. This way, I connect. Or one thing you can do, let me fold it, make it short, and then I connect it. Got connected before all of you. So one thing now I am getting ready to show you. First I have to show you that the lamp is glowing or not. Zoom out so that we can see other things. The coil is here and the solenoid is here. Let the solenoid be like this so that it will be easy for me to test this pole. First, let us test whether the lamp is glowing or not. This is more important. Oh, that's good. That means the coil is carrying, the solenoid is carrying, you can see, because the current is being fed to the lamp in series with the solenoid. Again, the return current is in series with the coil, and that goes to the source. You can check. So, first, what we have to do, I have already told you, I remove the iron core and then place this compass as usual. Let it be stable. And when I point my solenoid there, you will find how is the deflection. Yes, it is having a deflection. You could see, I want to show you by zoom. From the N position, it has been deflected. If I switch it off, it comes back. That means solenoid also has got a better magnetic effect that we could prove without the core. And now my duty is to introduce this core soft iron. Again, I zoom out. Sorry. Let me place the soft iron here. I do it like this. This is all before you because you have to see by yourself that things are not doing secretly. Now let us see. By placing the soft iron inside the solenoid and getting it on, the deflection increases or not. We have to confirm. Oh, nice. It is so nice. The needle got deflected by almost 70 to 75 degree or 60 degree, assume it. So initially it was 20 degree. Now after placing the soft iron, it is coming to 60 degree deflection. So it is a great observation. So that means solenoids are also used extensively in industry markets. Remember, solenoids are extensively used in electronic industry and electrical industry for robotic mechanisms. Solenoids are best for operation. But in motor industry, the coils are the best. And now what I want to do, all before you, I will remove this soft iron core from the solenoid. And thereafter I will use it again in the coil because I did not show if I place the coil with the soft iron what will be the effect. It should be observed carefully. And now I place the coil like this and get the switch on so that let the lamp should glow and lamp is glowing. Confirm and the deflection in the needle you could observe. And after introducing the software, and you will find that will be enhanced, but not like solenoid because the solenoid is perfectly fit for this iron core. But here there is a lot of gap between coil and the iron core. And in electrical industry, the gaps are not advisable. They are losing the energy. So you can see it is lightly changing by introducing the soft iron. If you do not, it is slightly changing. If you provide, it is reflected little more only, but not that prominent. Anyway, we got everything observed, and now it is time for me to show you how the coils are extensively used in electrical industry. So I have to remove everything. I have to show you the beautiful part of my future journey. Acha, one thing I forgot. I should not. I should have shown it. What is that? Lamp is glowing now, and you could see the coil is there. It is there with me, and I did one innovation yesterday with me. I do have a bar magnet placed on a bearing. You see, bearing is here. Bearing is on this particular base. That means magnet is free to rotate, and you could see if I hold it, magnet can be rotated beautiful way. Now what I am to show you, let the magnet be here and you see this is the north pole and you observe I keep it this side and this is so fascinating. Even though this is not suspended, this will go back to its normal position as it is done by a compass. Every magnet points north south and this is a proof. See, little change I do, it goes back. That means this bearing arrangement is very effective for me to show you my today's experiment directly online. So what is that? Let this coil be here and when I switch it off, it will be like this. And when I switch it on, you will observe Again, observe, I switch it off. This is a bar magnet, but this responds extensively and efficiently. You can again observe the north end points this side. That means the coils, this face behaves like a south pole, and the other side behaves like a north pole. I have to confirm that because if I keep this magnet this side and allow the current to flow, let us check which side comes to the coil. Repeating what I am repeating, coil face is same. I switch it off, and you see the bar magnet responds as usual because the north pole is this side. And now what I am doing, I switch on the lamp, and what happens, that all before you. See, the coil attracts the south pole this side. That means every coil has got even the same principle, north pole, south pole. So this side will be north pole and this side will be south pole. No, although the reverse I said, the south pole is getting attracted. So this side is north pole and this side is south pole. So that's all about. I switch it off and the magnet should go back to its own position, and thereafter I have to switch over to my today's new concept, and we will be going forward with that particular arrangement in future programs. So what is that? Let me show you. After removing everything, I have arranged. I have morning actually I have opened my heavy duty fan for all of you to see. What I want to show you, this is the idea, and let me keep it fast perfectly. This has been opened today, mind it. The fan which I use in my home. You see, all along there are coils. I saw the light also. More light, more observation. I think it will be suitable for all of you to see the internal arrangement of the alternating current motors you are using at your home. These are common things, everybody is using table fan, ceiling fan, pedestal fans. All these electrical motors are alternating current motors, and they have so many coils. I saw the coils individually. Here is a coil, here is a coil, here is a coil. So, how many coils if you count? I think one, two, three, four, five, six, seven, 8 coils are there. Remember, 8 coils are fitted inside the soft iron core, and everything I will discuss in my future program. But today I just showed you because I had a curiosity in my mind that I should show that the coils find extensive use in electrical industry. And now this is time for all of us to have a discussion over chat. I do not know how many people joined and how many people left, but it does not matter me. I am constant in my determination. So those who are present, can you provide your feedback at present? How did you like it? Whether this program is effective for all of us or not? Madam, how is that? You have written so nice, sir. Actually, I understand, but can you write now in further chat? Utkal, can you write if you are present? I do not know. There is no response. So I do not. I have already told you, my viewers actually they should be a little more interactive because whatever labor I am doing for my viewers, especially for the online viewers and those who want to see later on. They are also welcome because they will be seeing, they will be observing in the video content because luckily they are saved by our platform. So YouTube uh, deserves a praise because whatever we are doing, they do not go waste. They preserve all these things for future viewers. See the last part of the motor where the shaft enters through is a bush. In a mechanical language, bush is almost equivalent to a bearing, but not exactly. Bearings are little costly, but they do not have any sound. But here, whatever arrangement they have made, it seems to me like a bush. I have not opened further. So these bush they provide frictionless condition. Okay, so I hope there are three people now. Can you interact with me now? Is this program effective for all of us or not? That you must write down on your chat box. And with that, I will be coming to the end because as per my plan, the whole arrangement was complete within 30 minutes, and it is glad I'm glad enough to learn that time is very suitable for this because if I continue for 1 hour, it will be just gossiping. The content is displayed, demonstrated, but the questions from your end is invited. Last 5 minutes, I have to wait. There is no question from anybody. So if I interpret this, there is no question from anybody. That means whether we are trying to understand or not is a big question because electrical concepts many people do not like even, but those who at least see they will understand so many things. Because life is very important. Remember, just to have certain songs and dance is not the objective of our life. थोड़ा गाना गा ले और थोड़ा मुस्कुराए और ये जिंदगी खत्म हो जाए ये तो अच्छा नहीं है क्योंकि साइंटिस्ट लोग हमारे लिए कितने काम किए हैं और हम थोड़ा बहुत उनका काम को समझे और अप्रिशिएट करें ताकि उनका जो सोल है उनको थोड़ा सुकून मिले ये तो हमारा इरादा है ना human being as a human being what is our duty we should give respect to all those scientific people who have submitted who have rendered great knowledge to us and because of their knowledge these many things have been made and they are supporting our life in modern day life we are getting comfort because of them only all electrical components in your house they are run by alternating current and including this motor so we should be grateful to them to somehow. So now my final question to all of you before I end, who will be credited for the electromagnetic induction experiment which led to a great evolution and revolution in electrical industry? So please mention the name of the scientist before we leave the program. If you do not know, I give you option. Option 1, Michael Faraday. Option 2, Marconi. These two options are given to you and you have to choose electromagnetic induction experiments, the credit goes to which famous scientist? You could write and I will complete. If you do not write, you write afterward in your comment box. Thank you for being with me for half an hour at least. So I'm happy that you have spent that much of time for all of us. See you again. Thanks. Have a nice day.